Lesson today is about applications of quadratic equations. So by the end of the lesson, you should be able to apply your knowledge of quadratic functions to solve practical problems. Now, you need some steps. First, you must read the worded problem carefully and highlight any relevant information. Then define a pronumeral to represent the unknown. Always be precise. So you must say, for example, let L be the length of the rectangle, not L equals the length. And then formulate the quadratic equation, solve the equation, and note that sometimes you may not be able to accept both answers. Then answer the question in words. Alright, let's begin. First, problems. Matthew wishes to enclose a rectangular area in the backyard to protect his chickens. He wants to use the two existing walls of his house and has 20 meters of fencing materials for the other two sides. What is the maximum area he can enclose, and what would be the dimensions given this area? Alright, first I would actually sketch a diagram. So we know that there are existing walls and he has two sides of the fence to actually build. So now we can define. I'm going to let W and L be the width and length of the rectangular area and A be the area of the rectangular area. Right, let's start solving this problem. Since the fencing materials available is 20 meters, therefore, we know that W plus L equals 20. Rearranging it, we therefore know W equals 20 minus L. The area of the rectangle, A is equal to WL, and substituting, we know that A equals L into 20 minus L, since we are substituting W as 20 minus L. Now, in order to solve for the maximum areas, we need to expand the equations. Using your knowledge of quadratic, you know that since the coefficient of L squared is minus 1, the shape of the parabola is concave down and the maximum area occurs at the turning point. To determine the turning point, we need to find the axis of symmetry. We could actually solve the quadratic equation 0 equals to 20, L minus L squared. Therefore, L equals to 0 or 20. We know then the axis of symmetry occurs at the midpoint of 0 and 20, and therefore L equals to 10 meters. Hence, we can calculate W and A. W is 20 minus L equals to 10 meters, and A equals to 10 times 10 equals to 100 meters square. And we answer the question. The length and the width of the rectangular area is 10 meters and 10 meters respectively, and the area is 100 meters square. Now, I am actually going to show you how to solve this problem using your class pad. So get your class pad out and we shall go through how to solve it using class pad. Alright, let's have a look at this question, which is looking at determining the maximum area for the rectangular fenced area. Alright, we go to graph and table. This time, when we start with a new question, like I always said, you must always clear all. Make sure that you clear everything so that you can start fresh. Alright? So here, what I'm going to do is actually put in a formula. Instead of W and L or A and L, I will assume that the area is Y, and then X will be the length. So X into 20 minus X. Alright? And we'll click OK here. And let's draw the graph. Alright, you can see that the graph is really span quite a bit of the area. So we can use zoom out to actually find the maximum. Keep going. Zoom out. Zoom out. One more time. Of course, there are other way of using it. A little bit easier if you actually go and set your x and y axis. So this time, if I make the x minimum to be, let's say, -4, and x maximum is, let's say, 22. All right, let's click OK. And you can see that the graph is redrawn. You've got a easier parabola to actually work with. Now, to find the maximum value, you go to Analysis, GSolve, and you click Max here. Max, and then the calculator will show you where the maximum is, which is 10 and 100. So it's 10 meters and the area is 100 meters square. All right. If you want to find the intercept, you can go to Analysis, GSolve, and the root. And it will find the first root, which is 0, 0. And then the next one, just use your cursor. It will tell you the other root. All right, that is how you actually use your class pad to solve this problem. Right. Second example. A ball is thrown vertically into the air so that its height h meters above the ground after t seconds is given by the equation h equals 1.5 plus 5t minus 0.5t squared. So we need to answer 5 questions, starting off with the maximum height the ball reaches. Now we know that h equals 1.5 plus 5t minus 0.5t squared, and we also know that the maximum height or the turning point occurs at the axis of symmetry. So we can use y equals to minus, actually is x equals to minus b over 2a, or in this case, because we are using h and t is actually minus b over 2a. And we know that b is actually 5 and a is minus 0.5. So we can work out t actually equals to 5. So substituting it into that equation, h therefore equals to 14 meters. So the maximum height the ball reaches is 14 meters. Part B, since we have worked it out in part A, so the ball reaches its maximum height after 5 seconds. Part C, you need to work out when h equals to 6 meters. Now, 6 equals 1.5 plus 5t minus 0.5t squared, substituting h at 6. And rearranging it, we know that 4.5 plus 5t minus 0.5t squared equals to 0. Might be able to solve it, but if we don't have a calculator, we actually need to work it out by multiplying both sides by 2, so that we work with the whole numbers. Rearranging, we have t squared minus 10t minus 9 equal to 0. And factorizing, we know t minus 9, t minus 1 equals to 0. Therefore, t is 1 or 9. So the ball is 6 meters above the ground 1 second after it is thrown into the air. And when it starts to fall to the ground, it will again be 6 meters above the ground at 9 seconds. Now, let's have a look at what is the time the ball returned to the ground. So we know in this case, h should be 0. And substituting h equals to 0 into the equation, we know that 0 equals 1.5 plus 5t minus 0.5t squared. Again, rearranging and multiplying both sides by 2, we know that t squared minus 10t minus 3 equals to 0. Then we complete the square. And we have t minus 5 all squared minus 28 equals to 0. Therefore, t minus 5 equals to plus or minus square root of 28, and t is 5 plus or minus square root of 28. Now this time, you must reject t equals to minus 0.29. I actually use the calculator to work out minus 0.29 or 10.29 because we know that when we start throw the ball up, vertically up, time equals to 0. Therefore, it cannot be a negative value. So reject negative values and the ball will take 10.29 seconds to reach the ground. Now, how do we sketch the graph? The important feature of the graph, we know that it's concave down, so we know the maximum turning point. We know turning point is 5, 14, and the y-intercept is actually the initial point, which is when t equals 0 is 0, 1.5. So this is the initial. This is the turning point. And finally, x-intercept is the end point. This is what you have calculated, which is 10.290. So here you can sketch the graph, and if you're asked to determine the domain and the range, you will know that this is where domain and range is important. Because the domain, you start from 0, and when it reaches the ground, that's the end, which is 10.29. And the range, you start from 0, the ground, all the way up to 14 meters above. Again, I'm going to show you how to use your class pad. This time, you are talking about the ball being thrown vertically into the air. So again, instead of h and t, I'm going to use y and x. So y is therefore 1.5 plus 5x minus 0.5x to the power of 2. And then we can actually sketch it. Again, you can see that the graph is way above the grid. Again, we can zoom out. And then what we can do is could either drag it down and we can see the whole parabola. Again, let's use analysis GSolve. GSolve can tell us the maximum. Alright, see, it gives you the maximum, which is 5 and 14, which is what we find. Now, if we want to find the height, the time when the height is 6 meters, we go to analysis GSolve again. This time, we need x cal, y cal. We are looking for x, which is the time, knowing the y. So it will ask you the y value, which is h. So if we type in 6 and click OK, it will give you the first value, and then use the cursor. It will find you the next value. So you know that is t equals to 1 or t equals to 9. It is solved. The next one, you need to find the roots. Again, GSolve, root. It will give you the two roots, x-intercept minus 0.29, which we should reject, and also 10.29. This is what we'll accept. Now, you can actually zoom out again to actually draw it a little bit better, or use your scale. So if I go x minimum as minus 0.5, maximum as, let's say 10.5, and click OK, you can see that the graph is sketched for you. Alright, remember, this graph shows you the whole domain and the range, and you actually need to restrict the domain and range when you actually sketch it. That's all using the class pad. This is the end of the lesson. You should know how to apply your knowledge of quadratic function in terms of solving problems, and you should know how to use your class pad to solve the problems. Thank you for listening.